Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video, we're going to learn how to use the distance formula to find the distance between 2 points on a graph. So before we begin, let's start with the distance formula. Say you have 2 points, x1, y1, meaning the first x coordinate and the first y coordinate, and x2, y2. Then the distance, d, is equal to the square root of the quantity x2 minus x1 squared. That's the distance between the x coordinates squared, plus the same thing with the y coordinates, parentheses y2 minus y1, close parentheses, squared. So we find out how far apart the x coordinates are and the y coordinates are. We square those distances, add it together, and then take the square root. So our first point, and it does say to find the exact answer and approximate to the nearest tenth if necessary. So our first problem involves the points 3, 6, and 8, 18. So I'm going to label those as x1, y1, x2, and y2. So when I go to my formula, I'm going to rewrite the formula. Square root quantity of x2 minus x1 squared plus y2 minus y1 quantity squared. Then I can just substitute those values right in. x2 is 8 minus x1 is 3, and that's going to be squared, plus, in parentheses, y2 is 18 minus y1 is 6, and that's going to be squared. Now it's an arithmetic problem. 8 minus 3 is 5, so we have d equals the square root of 5 squared plus 18 minus 6 is 12. So that's plus 12 squared. Now we work out the radicand. 5 squared is 25 plus 12 squared is 144. That gives us the square root of 169, which we happen to know is equal to 13. So the distance between those 2 points is 13 units. By the way, didn't mention it, but the distance formula is really the Pythagorean Theorem in hiding. To find the hypotenuse, you square each of the legs and total them and then take the square root. That's basically what we've done here. If you think about 2 points, that is the difference between the 2 x coordinates. That's the difference between the 2 y coordinates, and we're missing the hypotenuse. And so we can use the Pythagorean theorem to get that. Let's try one more problem with just finding distances first. So this time we've got -5, 2 and -3, -10. I'll label those again, x1, y1, whoops. Didn't need to do that. X2 and y2. And so I've got the formula still written above, so I'm going to go right into the formula. It's the square root of x2, which is -3, minus x1, which was -5, all squared. And y2 minus y1 is -10 minus 2 squared. Let's see what we've got. -3 minus -5 is the same as -3 plus 5. And -3 plus 5 is 2. So I've got the square root of 2 squared plus -10 minus 2 is -12. So we have plus -12 squared. 2 squared is 4. -12 squared is 144. So when we add those together, we get the distance is the square root of 148. Now, I don't know what the square root of 148 is. That's not a perfect square, but I can simplify this first. I know that 148 is the same as 4 times 37. 37's prime, but I do know the square root of 4 is 2. So the exact value is 2 square root 37. Now, to get an approximation, the problem said to approximate to the nearest tenth, I need to turn to the calculator. 2 root 37 is exact. Let's go to the scientific calculator to get the approximation. Got my calculator open, and I can type 2 times square root 37. And to the nearest tenth, 12.16 is 12.2. I also could have used the original number before I simplified it, square root 148, also 12.17. So approximately 12.2. All right, a couple of applications of the distance formula. The first one says, do these 3 points form a right triangle? So what we know about a right triangle is that the square of one side added to the square of the second side has to equal the square of the third side. So the sides are the distances between those 3 points. We're going to find the distances for all three. Then we're going to see if the two smaller ones, when squared and totaled, equals the square of the third one. So first, I'm going to find the distance from A to B. And A is -3, -5. B is 2, -2. So this distance is going to be the square root of the second x, which is 2, minus the first x coordinate, -3. And that's going to be squared. Do the same thing with the y coordinates. That's -2 minus -5, all squared. 2 minus -3 is the same as 2 plus 3. So this first distance is going to be the square root of 5 squared plus -2 plus 5 is +3. So that's 3 squared. And 5 squared is 25 plus 3 squared is 9. That adds up to be 34. So that first distance is the square root of 34. Next, let's do A to C. Now we're working with -3, -5, and -7, 0. So it's the same as the formula we just used, but the x2 and y2 are going to change out to this new point. D equals the square root of x2, -7, minus -3, and that's going to be squared, plus, do the same thing with the y coordinates. Now I've got 0 minus -5. That's going to be squared. Again, -7 minus -3 is the same as -7 plus 3, and 0 minus -5 is the same thing as 0 plus 5. So this distance is going to be the square root of -4 squared, -7 plus 3, plus 5 squared, 0 plus 5. -4 squared is 16, 5 squared is 25. So that is the square root of 41. 1 to go, and that's BC. So I'm going to put that one down here. Now we're working with these 2 points. 2, -2, and -7, 0. Square root x2 is -7 minus x1 is now 2. Squared plus, it's going to be 0 minus -2 squared. -7 minus 2 is -9. So we've got the square root of -9 squared plus 0 minus -2 is 0 plus 2, or 2 squared. -9 squared is 81. 2 squared is 4, so that equals 85. So this distance is the square root of 85. This is the longest one, so if this is a right triangle, that would be the hypotenuse. So we want to see if the square of the two smaller legs totals to be the square of this potential hypotenuse. So I'm going to write lowercase a squared plus lowercase b squared equals lowercase c squared. And it's going to be root 34 squared plus root 41 squared does that equal root 85 squared? And that's what we're trying to figure out. When we square a square root, they basically undo each other. So we're left with 34 plus 41. Does that equal 85? No. 34 plus 41 is 75. So if that last distance had been the square root of 75, then yeah, this is a right triangle. But because in this case, a squared plus b squared does not equal c squared, then the answer is no, this is not a right triangle. Another problem that we can do involving distances is trying to figure out whether 3 points are collinear. Collinear is just a fancy term for on the same line. Co-line, on the same line. So what we do here is we find the distances, all three distances again, and what we're trying to figure out on a line is if these 3 points are all on the same line, the two shorter distances should add up to equal the longer distance. So we're going to find 3 distances and we're going to add the 2 shorter ones and see if they equal the longer one. I'm going to start with AB. This distance is going to be, the points, by the way, were -1, 6 for A, 1, 4 for B, and 9, -4 for C. So subtracting the x-coordinates, 1 minus -1 quantity squared. Subtracting the y-coordinates, that's 4 minus 6 quantity squared. 1 minus -1 is the same as 1 plus 1. So this is the square root of 2 squared plus 4 minus 6, that's -2, so that's -2 squared. Both of those squares are equal to 4, and 4 plus 4 is 8. So the first distance is the square root of 8. Now let's do AC. I'm going to write this right underneath that. For AC, now we're using -1, 6 and 9, -4. So it's the square root of the second x-coordinate, 9, minus the first one, -1, quantity squared. Do the same thing with the y-coordinates, plus the second y-coordinate was -4, minus the first one was 6, quantity squared. 9 minus -1 is the same as 9 plus 1. So this becomes the square root of 10 squared plus -4 minus 6 is -10 squared. And so we've got 100 plus 100 in the radicand, or 200. So D equals the square root of 200. 1 to go, and that's the distance between B and C. I'll put that here. Now we're using 1, 4, and 9, -4. D equals the square root. Start with the x-coordinates, 9 minus 1, quantity squared, plus the y-coordinates, -4 minus 4, quantity squared. 9 minus 1 is 8. So we've got the square root of 8 squared plus -4 minus 4, that's -8 squared. 8 squared and -8 squared both equal 64. When we add those together, we get 128. And so those are our 3 distances. And we can tell the longest one is AC. It's the square root of 200, which is greater than the square root of 8 or the square root of 128. So what we're trying to figure out now is the smallest one, the square root of 8, plus the next smallest one, the square root of 128. Does that equal the square root of 200? And unfortunately, we can't tell. We've got to simplify these first. The square root of 8, 8 is 4 times 2, so that becomes 2 square root of 2. 128 is 64 times 2. We know the square root of 64 is 8, so that can come out, 8 square root of 2. Finally, 200 on the right-hand side, that equals 100 times 2, and we know the square root of 100 is 10. So this is 10 square root of 2. And we have a true equation. 2 square root 2 plus 8 square root 2 does equal 10 square root of 2. Because these are equal, then the points are collinear. All right. That's it for the distance formula and a couple of its uses. What you want to be careful of here is first make sure you know the formula and that you can simplify using the formula. Be really careful when the coordinates are negative. Remember that subtracting a negative number is equivalent to adding a positive number. Then we can use the distance formula in a couple of ways. We can figure out a point to form a right triangle by seeing if the three distances satisfy the Pythagorean theorem. We can figure out if the 3 points are collinear if two of the distances total to equal the third one.